In 1963, a group of hot rodders in California figured out something that Pontiac's own engineers hadn't. They discovered that the factory 421 cubic inch V8, the engine Pontiac was selling as their performance flagship, was actually being held back, not by design limitations, not by manufacturing constraints, by corporate politics. These weren't engineers with degrees. They were guys with grease under their fingernails, working in small shops, racing on weekends, and swapping secrets at drive-ins. And within 18 months, they had built engines that outperformed anything coming out of Pontiac's official racing program.
The Catalina here on the Pontiac out there. Really nice stuff. It is the Catalina with
the factory noticed. And what happened next changed how Detroit thought about the relationship between street racers and corporate engineering forever. So, the early 1960s. The horsepower wars were just getting started. General Motors had 5 divisions, and every single one of them wanted to be the performance leader. Chevrolet had the small block 327. Oldsmobile had their rocket engines. Buick was doing weird things with aluminum. And Pontiac? Pontiac was trying to figure out who they even were. For most of the 1950s, Pontiac had been your grandfather's car, reliable, boring, the kind of thing a dentist drove. Sales were declining. The average Pontiac buyer was over 50 years old. The brand was dying slowly, and everyone at General Motors knew it. Then Bunky Knudsen showed up. Seaman Bunky Knudsen became Pontiac's general manager in 1956. He was 43 years old, which made him the youngest division head in GM history at that point. And he had one clear mission: make Pontiac interesting or watch it get killed off. His first move was to go racing. Not officially, of course. General Motors had signed the 1957 Automobile Manufacturers Association ban on factory racing involvement. On paper, nobody at GM was supposed to be building race cars or supporting racing teams. In reality, the ban was a joke. Every manufacturer found ways around it. They called it technical assistance, or engineering evaluation, or whatever language the lawyers approved. Pontiac's approach was to develop high-performance engines and parts, sell them over the counter through dealers, and let independent racers figure out how to make them fast. It was arm's-length involvement, technically legal, completely transparent to anyone paying attention. The engine at the center of this strategy was the 421. Now, the 421 wasn't originally designed as a race engine. It evolved from Pontiac's standard V8 architecture, which dated back to 1955. The basic design was solid but unremarkable. Cast iron block, overhead valves, wedge-shaped combustion chambers. Nothing revolutionary. What made the 421 special was its size. 421 cubic inches of displacement. That's 6.9 liters for anyone thinking metric. In 1963, that was massive. Most performance engines from competitors were running 327 to 400 cubic inches. The 421 gave Pontiac a displacement advantage, and in that era, displacement was the cheapest path to horsepower. The factory Super Duty version of the 421 was rated at 405 horsepower. That number was a lie, but we'll get to that. The problem was, Pontiac's official racing support was limited and carefully controlled. They had a handful of factory-backed teams. They had engineers who would provide technical guidance, but the resources were thin, the bureaucracy was thick, and the speed of development was slow. Meanwhile, in Southern California, a completely different approach was taking shape. The hot rod culture that emerged from Southern California in the post-war years was built on a simple premise: take whatever the factories built and make it faster. These were mechanical tinkerers who learned by doing. They didn't have engineering degrees. They didn't have dyno facilities. They didn't have research budgets. What they had was track time, trial and error, and a network of knowledge sharing that moved faster than any corporate development program. By the early 60s, some of these hot rodders had started focusing specifically on Pontiac engines. The reasons were practical. Pontiacs were relatively cheap on the used car market. The engines had a reputation for being overbuilt, with thick cylinder walls and strong bottom ends, and there was less competition in the Pontiac performance space than with Chevrolet or Ford, which meant less established wisdom about what worked and more room for discovery. The breakthrough came from cylinder head modifications. The factory Pontiac heads were decent. They flowed adequately for a street engine, but they were designed with manufacturing simplicity in mind, not maximum performance. The ports were small and restrictive. The combustion chambers were inefficient. The valve angles compromised flow at high RPM. A group of racers, working independently but sharing information, started experimenting with port modifications. They enlarged the intake and exhaust ports. They reshaped the combustion chambers. They changed valve angles and installed larger valves. Some of these modifications required cutting into the head castings in ways that would void any warranty and probably terrified the original engineers. The results were dramatic. Engines that the factory rated at 405 horsepower were suddenly making over 500 on the dyno. Same basic rotating assembly, same carburation, just modified heads. Word spread quickly. In the hot rod community, successful modifications became open secrets. Someone would figure out a new technique, share it with friends, and within weeks it would be common knowledge at tracks across the region. Here's where it gets interesting. Pontiac's engineering department started hearing about these modified engines. At first, the response was skepticism. Factory engineers tend to believe they've optimized everything already. The idea that some guy in a garage could outperform corporate R&D with hand tools was professionally insulting, but the evidence kept accumulating. These modified Pontiacs were winning races. They were setting records at drag strips. They were beating engines with factory racing support and professional development budgets. Eventually, curiosity overcame pride. Pontiac engineers started quietly acquiring some of these modified heads. They brought them back to the factory. They flow tested them. They measured every dimension. They compared the modifications to their own designs. Quick thing. If this is your kind of content, subscribe. We do deep dives like this regularly. Anyway, what they found was humbling. The hot rodders had discovered flow improvements that the factory engineers had missed. Some of the modifications were crude, yes, rough port work done with hand grinders, chamber modifications that varied from head to head. But the underlying concepts were sound. In some cases, the amateur modifications showed better understanding of airflow dynamics than the factory designs. The specific gains came from several areas. First, the intake ports. The factory ports had a sharp transition from the intake manifold to the port runner. This created turbulence that disrupted airflow. The hot rodders had figured out that smoothing this transition and opening up the port entry dramatically improved flow. They called it port matching, and it became standard practice. Second, the combustion chamber shape. The factory chambers were designed for easy casting and consistent volume, not for efficient combustion. The hot rodders had experimented with reshaping the chambers to improve the flame propagation pattern. This allowed higher compression ratios without detonation, which meant more power from the same fuel. Third, and this was the clever part, the hot rodders had figured out that the factory valve layout wasn't optimized for the cylinder head architecture. By modifying the valve seat angles and slightly relocating the valves within the chamber, they could improve both flow and combustion efficiency. This wasn't in any factory manual. It was pure empirical discovery. The total improvement from these modifications was substantial. Factory heads flowed around 200 cubic feet per minute on a flow bench. Modified heads were hitting 260, 270, sometimes approaching 300 CFM with aggressive work. That's a 30 to 50% improvement in the engine's ability to breathe. For context, airflow is everything in a naturally aspirated engine. More air in means more fuel can be burned, means more power out. The engine's displacement sets a theoretical maximum for how much air it can consume per cycle. But the heads, the ports, the valves, and the intake system determine how close you get to that theoretical maximum. The factory 421 was leaving maybe 25% of its potential on the table just from head design limitations. The hot rodders found that missing 25%. Now here's where corporate politics enter the story. Pontiac's engineering department was genuinely impressed by what they'd learned. They wanted to incorporate these improvements into future production heads. They wanted to develop a Super Duty engine that used these principles from the factory, but General Motors had layers of approval processes. And in 1963, the pressure to back away from performance was increasing, not decreasing. The AMA racing ban was still officially in effect. There was growing public concern about highway safety. Insurance companies were starting to pay attention to muscle car accident rates. Releasing a dramatically improved cylinder head design would be an obvious signal that Pontiac was still in the performance business. It would draw attention that corporate leadership didn't want. So the knowledge sat in engineering files. Some of it leaked into improved production designs over the following years, but incrementally, quietly, without fanfare. The hot rodders, meanwhile, kept pushing. By 1964, the best modified Pontiac 421s were making over 550 horsepower reliably. Some claimed over 600 with aggressive builds. These weren't dyno queens that would grenades after 10 passes. These were engines that raced all season, won championships, and proved the concepts were sound. The modification techniques spread beyond Southern California. The knowledge network that had developed through racing publications, through word of mouth, through the informal apprenticeship system of hot rod shops, carried these innovations across the country. A guy in Texas could read a magazine article about port modifications, correspond with someone in California who had done the work, and apply the principles to his own engine. The speed of this knowledge transfer in an era before the internet was remarkable. The factory relationship became more interesting over time. Pontiac engineers started developing unofficial relationships with some of the more sophisticated hot rod shops. They would provide technical information in exchange for feedback on modifications. It was a two-way exchange. The factory had resources, the hot rodders had real-world testing. Some of this collaboration showed up in parts that Pontiac released through their performance parts program. Improved intake manifolds that incorporated lessons learned from modified street engines, camshaft profiles that reflected real-world racing experience, header designs that were suspiciously similar to what the aftermarket had been selling for years. The 421 itself evolved. The 1964 version incorporated some cylinder head improvements that traced directly back to hot rodder discoveries. The ports were slightly larger, the combustion chambers were slightly better shaped. Nothing dramatic enough to draw corporate attention, but enough to improve performance. By 1965, the era was already changing. GM released the big block 454 architecture. Pontiac got the 428 and eventually the 455. The 421 became a footnote, replaced by engines with more displacement and more factory support. But the lessons from this period echoed forward. The Detroit manufacturers had learned something valuable. The hot rod community wasn't just a market for performance parts, it was a distributed research and development network. Thousands of amateur engineers running experiments every weekend, sharing results, iterating faster than any corporate program could manage. The idea of factory engineers studying amateur modifications seemed embarrassing in 1963. By the 1970s, it was standard practice. manufacturers actively cultivated relationships with the performance aftermarket. They hired people from hot rod backgrounds. They paid attention to what the tuning community was doing. This collaboration model persists today. When a factory releases a new performance engine, the aftermarket tears it apart within weeks. The discoveries feed back to the factory. The factory incorporates what works into the next revision. It's a loop. The specific technical lessons from the 421 era also persisted. Cylinder head porting became a recognized specialty. What those early hot rodders figured out with hand grinders and flow benches is now done with CNC machines and computational fluid dynamics. But the principles are the same. Port shape matters. Transition angles matter. Combustion chamber geometry matters. Valve placement matters. The flow numbers that seemed remarkable in 1963, 260, 270 CFM, are modest by modern standards. A well-developed modern small block head flows over 400 CFM, but the percentage improvements that the hot rodders achieved, 30 to 50% better than stock, remain the benchmark for what's possible with headwork alone. The compression ratio games they played also established principles that lasted. The idea that chamber shape affects detonation resistance, not just compression ratio, is now textbook material. Modern engine management systems can adjust timing and fuel delivery to optimize for different chamber designs, but the underlying physics are what those guys discovered with nothing but trial and error. There's something else worth noting. The 421 hot rodders proved that expertise doesn't require credentials. These weren't engineers in any formal sense. They were mechanics, machinists, and enthusiasts who paid attention, experimented systematically, and shared what they learned. They outperformed professionals with better resources because they had better feedback loops and fewer institutional constraints. That dynamic shows up repeatedly in technological history. The experts miss something, the amateurs find it. The experts initially dismiss the discovery. Eventually, the evidence becomes undeniable. The amateurs get absorbed into the professional world, or their techniques get adopted and institutionalized. Today, if you want to see surviving evidence of this era, you have to look carefully. Original Super Duty 421s are collector items. The modified heads that taught Pontiac's engineers are probably sitting in garages, unrecognized, or were scrapped decades ago. The knowledge persists in books, in magazine archives, and in the memories of people who were there. A few of the original hot rodders from that period went on to careers in professional racing or aftermarket manufacturing. Some of them are still alive in their 80s now, and they'll tell you stories about figuring out things that the factory didn't know. There's pride in that. Earned pride. The Pontiac 421 isn't remembered as one of the great American engines. It doesn't have the cultural status of the Chevrolet small block or the Ford FE, but it might be the most important engine in terms of demonstrating what amateur expertise could achieve when the factory wasn't paying attention. The factory started paying attention. They never stopped. Modern performance engineering is built on feedback loops between manufacturers and enthusiasts. The Internet accelerated this to the point where factory engineers monitor tuning forums in real time. A modification that works gets noticed within days. The barriers between professional and amateur expertise have blurred almost completely. But it started somewhere. It started with guys in California garages, hand-porting cylinder heads, sharing what worked, and eventually teaching Pontiac how to build a better engine. They didn't get credit at the time. They didn't get paid. They just wanted to go faster. And in the process, they proved that the factory didn't always know best. That's still true today. It always will be. So that's the story of the Pontiac 421 and the hot rodders who knew more than Detroit. Still remarkable that factory engineers ended up studying amateur modifications. Let me know in the comments if you've got any connection to this era or if there's something I missed. Subscribe if you want more stories like this. We've got plenty.